Okay, just confirm before we start. Can you see my screen so that we get started?
Yes, I can see your screen.
It's okay. Can I just answer this? Hello, Mama. Round four. It's okay. Quiet. Okay, let's get busy. Let me start my recording. So today, introductory is a hypothesis testing. So we want to look at hypothesis testing. Okay, so in the last session, we did introduce hypothesis testing. So today we want to move on from what we were discussing in the previous session. The last thing, of course, the main issue in the last discussion was the confidence. It was the confidence intervals. We're looking at the limits, the confidence limits. Today, we want to talk about hypothesis testing, which marks chapter 7 of your module. So we want to look at hypothesis testing. Hopefully, we'll be able to cover all of it today so that in the next session, we can look at regression and correlation. Okay, so let's start with understanding and maybe a quick recap of what we did talk about in the last session. We did mention that the field of statistics, the hypothesis testing, it is more concerned with testing claims. Someone comes up with a claim, and we can't really say this person is lying before we can prove that their claim is false. So hypothesis testing is a branch of statistics that we use to test the claims that the people might have made. So someone can say, I have created a drug for cancer that can cure cancer. We can test that. Do their drug really cure cancer? So the claim is what we are testing under hypothesis testing. So in hypothesis testing, we can have what we call the null and the alternative hypothesis. Again, we discussed this in the last session, but I'll just briefly highlight them again. So the null and the null and the alternative hypothesis. So when we are testing that claim that someone is came up with, so if I give a claim and you're doubting that my claim could be false, you can carry out a hypothesis test to prove whether that claim is correct or not. So we have what we call the null hypothesis, and we have, the alternative hypothesis. The null hypothesis states that the claim is false. So there is no change. So the null hypothesis, it would, okay, if there was no cure, even now, there is no cure. There isn't anything that has changed. This person is lying. So the now hypothesis is saying, no, nothing has changed. We don't have a cure yet. But H1 is what we call the alternative hypothesis. It's saying their claim is true. So there are two things here. H naught is saying no. H naught is for the side that is saying no, nothing has changed. But H1 is in support of the claim. H1, or we can call it the alternative hypothesis, is agreeing that there is a change, is agreeing that the claim is true. So we have to either accept H naught, the null hypothesis, or we have to accept the alternative hypothesis. We conduct a test with the aim of either supporting the null hypothesis or supporting the alternative hypothesis. So we want to find which side to support. Should we go for the null hypothesis or should we go for the alternative hypothesis? So let's now move on. So we test a claim with the aim of identifying whether we should go with the null hypothesis or the alternative, which is saying now there is a change. We also did talk about there's a type 1 error that could be committed, and we can also commit a type 2 error. What is a type 1 error? Type 1 error is committed when a true null hypothesis is rejected. So we are saying someone comes up and says, I have a cure for cancer. And we know there was no cure for cancer, and they say, I have a cure for cancer. Then we say their claim is true, and we reject what we know that there is no cure. So we are rejecting what was there in support of the new claim when the claim is actually false. So type 1 error, this is when a true null hypothesis is rejected. We are actually rejecting what was already there, not the claim. We are rejecting what we usually knew in support of the alternative, which is false. So we have rejected a true null hypothesis. A type 2 error is committed if we accept the null hypothesis when it is false. So the type 1 and type 2 is centered on the null hypothesis. Zvatagara tichiziva. Tikati isusu zvatagara tichiziva tikati zviri wrong, izvo zviri correct. That's type 1 error. Then tikasapota zvatagara tichiziva whilst zvisiri izvo zvechokwadi, that's a type 2 error. We are accepting the null hypothesis when it is actually false. This person is saying there is now a drug for cancer. They are saying the truth, but we say, no, you are lying. That's a type 2 error. If we agree with them, whilst there is no cure, that's a type 1 error. So there can be a type 1 error and there can be a type 2 error. Then now let's move on. If we are conducting a hypothesis test to test the claim, someone comes up with a claim, I have a cure for cancer. So there are steps that we have to undergo through to test that claim. So we can't just say, no, this person is lying or they're saying the truth. We have to conduct a test. So the test that we are going to conduct, which is the hypothesis test, they are about 6 steps that we have to go through. So let's start with the first step. So the first step, which is step 1, we have to identify the null and the alternative hypothesis. So the first step, which is step 1, involves identifying the null and the alternative hypothesis. So Triguti, someone comes up with a claim and we want to test whether their claim is true or false. Someone comes up with a claim and we want to test that the claim is true or false. We have to conduct a hypothesis test. So steps in hypothesis testing. So there are a number of steps atinofana kuita go through if we are conducting a hypothesis test. So what is the first step? The first step is to identify the null and the alternative hypothesis. Alternative hypothesis. Put in simple terms, if you're identifying the null hypothesis, this involves identifying what is currently present before the claim. Like if we are looking at cancer, there is no cure, that's the null hypothesis. So the null hypothesis is this is what is known before the claim. This is what is known before the claim. The null hypothesis is what we know before the claim. You identify the null hypothesis. Identify the null hypothesis. Okay, besides the null hypothesis, we need the alternative hypothesis. So the null hypothesis is saying there is no cure. That's the null hypothesis. Then we need the alternative hypothesis. The alternative hypothesis is opposing the null hypothesis. So this is the claim. So the claim could be there is now a cure. Someone is saying, I found a cure. There is a cure. So the alternative hypothesis opposes the null hypothesis, and the alternative hypothesis is based on the claim, on what someone is claiming. So the first step, understand, okay, we are testing a claim. What is the null and the alternative hypothesis say? Then step number 2, identify the distribution. So when we are, so the step number 2, step 2, identify the distribution. Identify the distribution. Photocopy. Chingotarisa unoshanda nemakombiyuta musi. Ungotarisa kumagetsi kuti yakabva. So identify the distribution. Identify the distribution. So if you're identifying the distribution, normally there are two distributions that we deal with. We have the normal distribution and the t distribution. So you look at the data that you're given and determine whether we are going to use the normal or z distribution. So we have the normal. If you were there in the last session, Padaita, the confidence interval, statistical estimation, we did make use of what we are going to talk about now. So normal distribution, we can have the normal distribution, which is also called the Z distribution. So you identify which distribution are you going to deal with. So you can have the normal or the Z distribution. When do we use the normal or Z distribution? The normal or Z distribution is used under the following cases. We can say this, we are using the distribution, the Z distribution or normal distribution, provided that the standard deviation is known. So this is used under the following cases. So the normal distribution, this is used, or rather, let me say A here. This is used provided that we are given the standard deviation. So we must be given the standard deviation. That's the first condition. This is used if we are given the standard deviation. If we are not given the standard deviation as well, we can use the normal distribution. But what should be the case? Sorry, this is used provided that we are given the population. Let's add the population standard deviation. If we are not given the population standard deviation, remember those steps in the confidence intervals. The case number 1 was saying, if we are given the standard population standard deviation, we use the normal distribution. Then, if we are not given the population standard deviation, we can also use the normal distribution if n is large. If n is large, that is greater than or equal to 30, greater or equal to 30. So we can also use the normal distribution, provided that the sample size is large. Our n is greater or equal to 30. By the way, if we are testing this claim, we need a sample. We test it on a sample. We'll take maybe 30 people with cancer. We'll take 40. We take 10. Then we test the drug that they are saying, no, this one cures cancer. Then we see the results. So if the sample size is large, that's greater than 30, is you use normal distribution. But if it's small now, if the standard deviation is not given, let's have t distribution. The t distribution. T distribution, this is used. This is used if the sample size is less than 30. Sample size n. N refers to the sample size is less than 30. The sample size is less than 30 and the standard deviation is not given. Is not given. The sample size is less than 30 and the standard deviation is not given. Sample size is less than 30 and the standard deviation is not given. Let's move on. So that's step number 2. Identify the distribution. Then let's move on. Step number 3. Determine the rejection criteria or the rejection and acceptance region. So we have determined we are using the normal distribution or the t distribution. Then we need to move to step 3. So step 3, this one is determining the rejection criteria. So what am I talking about if I say the rejection criteria? So the rejection criteria, we are saying at what point should we say the claim is correct, or at what point should we reject the claim? So we have tested maybe 30 people and 20 vapora need that drug. So someone is saying, I have a cure for cancer. So but I tested on 30 people. 20 vaporeswa zvesure. But the other 10 zvobva zvatoramba. Potoshaya kana sign yekuratidza kuti no, pane change. Then can we say the claim is true? Because they've tested on the number of people, some of them zvaita, some of them zvaramba. So the question is, when do we say the claim is true? When then do we say the claim is true and when do we say it is false? Do we accept kuti ichokwadi ane cure because pane vanhu 20 vaporeswa? And should we reject? If we can say yes at 20, then at what point do we say no? What about 15? What about 10 vakapora? What about vakaporeswa 5? So whenever we conduct a hypothesis test, we have what we call a significance level. So the hypothesis test is conducted at a certain significant level. The hypothesis test is conducted at a certain significance level. The significance level will tell us the level which we can say if ikasvika this level, vanhu vakaita this number, we can accept. So the significance level, it will tell us at what point should we reject. It can be 90% significance. It can be 99%. It could be 95%. So they will mention in the question, test at what significant level. So the significant level is the one that determines the rejection criteria. So we use the significance level. We use the significance level to determine the critical value. We use the significance level to determine what we call the critical value. The critical value, we get it from the tables. From if Kanatati distribution yedu is normal distribution, the critical value tunayoona from the normal distribution tables. Kanatati's T distribution tunayoona from the T distribution tables. The same way yataitsvaga the Z curve, paraita the confidence intervals. So the critical value is obtained from the tables, depending on the type of distribution. That is whether it's normal, or T distribution. So the type of distribution will be used to determine the critical value. The type of distribution is used to determine the critical value. Then, if the test is a two-tailed test, we share the significant level. We'll talk about the two-tailed test later on. So in hypothesis testing, we have a one-tailed test and a two-tailed test. But for now, let's leave it there. I'll show you using an example. So the step number 3 is to get the critical value. But the critical value is obtained based on the level of significance. We need the critical value based on the level of significance. And not just the level of significance. We also consider whether it's one-tailed test or it's a two-tailed test. Then after step number 3, after you've obtained the critical value, which you will use to either accept H naught or to reject H naught, we move then to step number 4. So now we have the critical value, we move to step number 4. We move to step number 4. So step number 4 is calculate the test statistic. Calculate the test statistic. So you calculate the test statistic. So if you're calculating the test statistics, this is what you compare. Remember, that isusu, we will reject at maybe 90% confidence interval, 99% confidence interval. Maybe we are saying the critical value can say, our critical value can be, let's say, out of the 30 people that are tested, e.g., the critical value can be This is just a lemon example. So critical value, let's say out of the 30, the critical value is saying 20. So it's saying if 20 people are cured, then we accept. But if those that are cured are less than 20, we reject. So now that we have the critical value of 20, we move to calculating the test statistic. If you are now calculating the test statistic, we are now calculating to see how many. This was just determining at what point do we cut off. Now we are testing those who have been cured to see how many have been cured. So if you're calculating the test statistic, this is based on the sample. This is based on the sample and the distribution. It's based on the sample and the distribution as well. So the test statistic is compared with the critical value. It is compared with the critical value in determining whether to accept or reject. Whether to accept or reject H naught or the null hypothesis. So we compare my results at no one from the test with the critical value. We compare the results with the critical value. But how do you conduct the test? There are formulas that we use. So to get the test statistic used to compare with the confidence, with the critical value. So I'm giving you the steps. Then next we are just going to apply it to my questions. So to get the to get the test statistic used to compare with the critical value, we use formulas. I will show you the formulas are there on the PDF. We use formulas. So let's go to the PDF. So test statistic, that's that's step number 4. So which formulas? They are here. If n is large, we use this one. N is large, we use the first two. If n is small, we use this. So the cases where we're saying for normal distribution, case 1 and case 2. For normal distribution, we use the first formula, the first two. They are the same, in fact. The difference is that the first one, we will be given the standard deviation. The second one will be using the sample standard deviation. Then case 3 is for t distribution. Don't worry, we'll get there. So step number 4 is to calculate the test statistic. Now, step number 5, this is where a decision is made. Decide whether or not to reject H naught. You compare the test statistic and the critical value. Then you make a decision. So you compare the test statistic and the critical value. You're comparing the answer for step 3 and step number 4 to make your decision. Then you make your decision in step number 6. So Statistics is not theory. We have to make calculations so that it sinks in your head. So let's move to, so I've talked about the critical value, but maybe something that I want us to talk about is the one-tailed and the two-tailed test. So in a one-tailed test, the alternative hypothesis is suggesting a one direction. What do I mean by a one direction? So someone can say, they can argue and say, let's say we know that the population, maybe with someone says, no, in Zimbabwe, we have, let's say 5 million, or we have 10 million population. Then someone says, no, that's not true. So they can either argue saying that the population is more than 10 million, or they can either argue saying the population is less than 10 million, or they can argue saying, I don't know the actual population, but it's not 10 million. It's either more or it's either less. So if it's a one-tailed test, the alternative hypothesis is suggesting that the actual results are either more or less. So one-tailed test. The alternative hypothesis is supporting one side, is supporting one side. That is either more or less. So the one-tailed test, the alternative hypothesis will be saying, no, the population is more than that. Or it will be saying, they'll be arguing, saying it's less than. Or in our example that we're dealing with, the alternative hypothesis would be saying there is a cure. It's just looking at one side. There is a cure. There are less than 10 million people. That is what the argument is saying. But a two-tailed test is looking at both sides. Two-tailed test. In a two-tailed test, the person is arguing, saying, the people in Zimbabwe are either more or less than, but they can't be 10 million. You are saying it's 10 million? No. They are saying it can be above or it can be less, but not 10 million. So a two-tailed test looks at two sides, either above or below. So someone is arguing, not necessarily saying they are more than 10 million or they are less than, but they're saying it's either they're more or less. So this is a test for change, where it argues that the current results are not correct. The current results are not correct. The actual results are either more or less. The actual results are supposed to be either more or less. So that is if it's a two-tailed test. It looks at both sides. The argument is both sides. So that's a one-tailed test and a two-tailed test. That's for a one-tailed test and a two-tailed test. Now, let's move on. Let's go to the first example. Let's go to the first example. The average weekly earnings of all bus rank marshals is reported to be, so what we are testing here is the mean. So the claim we are testing is the mean. Let me see if I can copy this to the Excel. Example 1. So this first example, the average weekly earnings of all bus rank marshals is reported to be 180. So we are saying the average earning is 180. That's the mean. We are saying on average, all bus rank marshals, they earn 180. That is the present. So in other words, H naught is saying the average is 180. The H naught, remember, so the average weekly earnings of all bus rank marshals is reported to be 180. You believe it is low. You believe it is too low. So if the average is said to be 180, so H naught is supporting what is there. So H naught, which is the null hypothesis, is saying, okay, on average, each bus rank marshal, they get 180. That's H naught. Then H1 is the alternative hypothesis. Let's read the alternative hypothesis and see what it is saying. So you believe it is too low. You collect a random sample of 100 marshals and find that the weekly average is 250 with a standard deviation of 20. Conduct a 10% level of significance. So they will not say this is H1. In some cases, they will give you, but in some cases, they will not say so. Your belief, your claim, your assumption is the H1. Because you want to test, you believe it's too low. So you believe it's supposed to be higher. So take note of the phrasing. If you believe something is too low, then it means your suggestion is that it should be higher. So you are told the mean is 180, but you believe it's too low. So what is the alternative hypothesis saying? So the alternative hypothesis is saying this average should be greater. The 180 is too low. It should be greater than 180. So the step number 1 is what we've already done here. So step 1, determine the null and alternative hypothesis. Determine the null and the alternative hypothesis. So that's the first step. Determine the null and the alternative hypothesis. That's the first step. Determine the null and the alternative hypothesis. So the null hypothesis is saying, no, ziripo is still correct. The alternative hypothesis is saying, no, that can't be correct. So the alternative is believing that is too low. So it should be greater than 180. Then step number 2, So for step number 2 now, step number 2, we need to determine the distribution. We determine the distribution. That's step number 2. So determining the distribution, we look at, do we have the standard deviation of the population? We are given, you collect a sample of 100 marshals and find that the average is 250 and the standard deviation. That's a standard deviation from the sample. So that one is the standard deviation of the sample, but we said we want the population standard deviation. So the standard deviation given is not for the population. So normal distribution is used provided that we are given the population standard deviation. We are not given the population standard deviation, but we are given the standard deviation of the sample. But the good thing is that the sample size is large. So we are not given the population standard deviation. We are not given the population standard deviation, but um, N, which is sample size, is large. We are not given the population standard deviation, but the sample size N is large. Hence we use the normal distribution. If N is large, we use the normal distribution. So we've determined the distribution. We are using the normal distribution. Step number 3. So for step number 3, this is where we are determining the rejection criteria. The rejection criteria. Remember, the rejection criteria, this is where we need for the rejection criteria, this is where we need the critical value. We need to determine the critical value. So the critical value, we first of all need the level of significance. Level of significance. So the level of significance will be stated on the question. They will say conduct a test at 10% level of significance. So we're conducting a test at 10% level of significance. So we're conducting a 10% level of significance. If it's a 10%, it means the level of significance is 0.1. 10% is simply 0.1. So for this one, we are not doing the same thing like we used to do to my critical values, where we would say 1 minus the confidence level. So here, if the level of significance is 10%, we just take that one as 0.1. We are testing at 10% level of significance, it's 0.1. Then the critical values. After you have the confidence level, the level of significance, 0.1, and we know this distribution is normal distribution. So you go to Z cow 0.1. Z cow 0.1 from the normal distribution tables. You go to Z cow 0.1 from the normal distribution tables. So let's go to the normal distribution tables. So the normal distribution tables. So these ones you are given in the exam, the tables. So let's look for the normal distribution tables. So these are the normal distribution tables. Areas under the normal curve. So this is the normal distribution table. So the Z cow is here. These are the values. The Z cow, these are the values. So we want 0.1, 10%. If we want 10%, we come and take 10% here. 1,2816. So Z cow is 1,2816. The Z cow um, Z 0.1 from the tables is our critical value. So is our critical value. So the critical value is 1.2816. Where did we get it? From the tables. So we need to get that from the tables. So that's step number 3. After we have obtained our critical value, maybe let's rather not call this from the table, let's not call it a Z cow, but let's call it the critical value. So after we've obtained the critical value from the tables, after we've obtained the critical value, we then say reject H naught. If the test statistic, that is the one that we're going to calculate in step number 4. We reject H naught if the test statistic is, remember we are saying H1 is greater than 180. So we reject H naught. We take the same sign. So H naught was saying greater than. So we reject H naught. H1, sorry, was saying no, it's supposed to be greater than 180. So we are saying we reject H naught if the test statistic is greater than the critical value. If we were looking for, if H1 was saying less than, we would say reject H naught if the test statistic is less than the critical value. Since in this case, the alternative hypothesis is saying that the average should be greater than 180. We reject H naught if the test statistic is greater than the critical value. Now let's move on. That's step number 3. Step number 4. So step number 4 is now calculating the test statistic. Calculating the test statistic. Calculating the test statistic. So this one is based on the distribution. If we say it's normal distribution, let's go to the formulas I gave you. So for normal distribution, we said we use the 2. So in this case, we were not given the standard deviation, but our n was large. So we are using this formula. Z cow is equals to x bar minus mu over standard deviation over square root of n. So calculating the test statistic. Z cow, which is the test statistic, is equals to, we can say the x bar or in fact, we say the x bar. The x bar, if we go to the question, they have given us the sample mean. So let's write in full. We are saying the sample mean minus the current mean. The sample mean minus the current mean over sample standard deviation over square root of n. Over square root of n. So that is what that formula is saying. Now let's substitute. So the sample mean, or let's first of all get the variables. So the sample mean from the question, the sample mean. So I doubt the mean is not 180, and they carried out a sample. And from they carried out an investigation from a sample. And from the sample, the mean was 250. So currently the average is 180, but it is 180. But Pandagaita the sample, I got 250. So it means the sample mean is what you are getting from the sample 250. The current mean, which H naught. So the current mean, this is according to H naught, is 180. Then sample standard deviation. The sample standard deviation is 20, and the sample size, we took a sample of 100 people. So let's confirm sample standard deviation there is 20, yes. And the sample size is 100. So let's substitute. Let's substitute into the formula. So it means our test statistic, Z cow, the test statistic is going to be the sample mean 250 minus the mean according to H naught 180, or divided by 20 over the square root of 100. Square root of 100 is 10. It's got 20 divided by 10 is 2. So let's move. So this would be 250 minus 180 divided by 2. 250 minus 180 divided by 2. So that would be 35. So that would be 35. So We have obtained 35. That's our test statistic. Test statistic is 35. This is what we will use to accept or reject H naught. Let's move on. Step number 4 has been done. Step number 5. So for step number 5, what did we say about step number 5? So step number 5, this is when we make the decision. So step number 5, let's check our steps there. Step number 5, decide whether or not to reject H naught. So we're just using what we've already talked about in Soro. So remember, we said on step number 3, what did we say on step number 3? The last thing on step number 3. Step number 3, reject H naught if the test statistic is greater than 1.2816. So make the decision. If we go back to step number 3, step number 3 was saying, let me recall step 3. Last point was saying, reject H naught if test statistic is greater than 1.2816. Reject H naught if the test statistic is greater than 1.2816. So therefore, since the test statistic Z cow is greater than, all right, we can say is 35, which is greater than which is greater than 1.28. We reject H naught. We reject H naught. So last step, which is step number 6, making a conclusion. So since we have rejected H naught, so what conclusion can we make? So the conclusion is, if we have rejected H naught, the conclusion is that H1 is correct. So how do you write that? We conclude that the average is not 180. It is now greater than, it was average earnings. The average earnings are not 180. They are now greater than 180. So that's the conclusion. So the conclusion is just repeating what H1 is saying, that the earnings are greater than 180. So those are the steps in hypothesis testing. The good part about hypothesis testing, it carries a lot of marks. So the calculations or the steps are worth it. But The bad side of it is if you don't know, it means you lose a lot of marks. So if you can master it, you get more marks. If you don't know it, you lose a lot. So those who manage to join, please confirm. Is there any questions of it? Pauline, Thelma, confirm any questions?
I don't have any questions.
Okay, Pauline? Okay, let's proceed. So that was question number 1. Let's have another question. But this time around, we want to deal with a two-tailed test. This one, it was a one-tailed test. Now we want a two-tailed test. Let me try to copy the question again and paste it on our Excel. So the second example is involving a two-tailed test. Involving a two-tailed test. So the question reads, a stock market analyst claims that the average annual returns on stock in the construction industry is 12%. So the analyst is saying the average annual return. So again, it's the same thing. They're saying average, it is 12. That's what H note is saying. The null hypothesis is saying that the average is 12. This is the null hypothesis supports what is there. It supports the current situation. You want to test whether this claim is true. You collect a sample of 36 stocks in the construction industry and find that the average return is 10% with a standard deviation of 3%. Use a 5% level of significance. So this one, the question did not mention whether you think it's greater or you think it's lower. You just want to test whether it's true. If you're testing whether it's true, it doesn't mean you are saying, because if it's 11, it's false. If it's 13, it's false. So they are saying it's 12. But if your test results are showing you 10 or they're showing you above, still it means then that claim is false. So we are saying that H naught is claiming the average is 12. So the null hypothesis is saying the average is 12. But the alternative hypothesis, we want to test that claim. So the claim, if we are testing the claim, it means we are doubting that the average is 12. We are saying the average is not 12. So if you're saying the average is not 12, the sign that we are supposed to use is the average is not equal to 12. Let me see if I can get not equal. Yes, here is the sign that I want. So H1 is saying the average is not equal to 12. H naught is saying the average is 12, but H1 is saying the average is not equal to 12. So H naught is saying the average is 12, but H1 is saying no, the average is not 12. So if the average is not 12, it means this is 12%, by the way. So if it's not 12%, it means it could be greater or it could be less than 12%. So H1 is just opposing, saying it's not 12. So that's step number one. Then step number two, let's determine. So what you need to be very careful with is to go opposite chiti kudi. What is the alternative? Is the alternative saying it should be higher? Is the alternative saying it shouldn't be 12? It can be less or more. Or is the alternative saying it should be lower? So step number two is determining the distribution. Determine the distribution. So that's the second step. Determine the distribution to use. So looking at the question, you collect a random sample, and we are not given the standard deviation of the population. We are given that the sample is 36, and from that sample, the standard deviation is 3. So n is large. We are not given the population standard deviation, but n is large. So we are not going to write much this time around. I think you now know. So you can say the population standard deviation is not given. Is not given. And n is large. Hence, we use the normal distribution. Hence, we use the normal distribution. We're done with step number two. Step number three. This one is determining the critical value or the rejection criteria. The same. So determining the critical value. So if you're determining the critical value, it means for determining the critical value, remember what we said, for the critical value, we consider the level of significance. So level of significance So the level of significance is 5%, so 0.05. However, it's a two-tailed test. For a two-tailed test, the level of significance is shared. For a two-tailed test, the level of significance is shared. So for a two-tailed test, we share the level of significance. So you'd say 0.05. Instead of just going to find 0.05 in my tables, you divide by 2 because we are looking for two levels. We are either saying it could be above or below. So we share that by 2. So 0.05 divided by 2, that would give us 0.025. So instead of looking for 0.5 in my tables, we find 0.025 because it's a two-tailed test. Then kana wakutsvaga kuma-tables, the critical value for a two-tailed test, is plus or minus. So the answer will be plus or minus. The answer that you get from the tables, it will be plus or minus. The answer that you get will be plus or minus. So if maybe it was the last question, it will be plus or minus 1 comma 2816. So let's go to the tables and find 0.025. Let's go and find our critical, let's go and find our critical value, 0.025. So from the table, 0.025 is the third one here. It's 1.96. 0.025 is the third one. It gives us 1.96. So the critical value becomes plus or minus. The critical value becomes plus or minus 1.96. So the critical value becomes plus or minus 1.96. 1.96 is from the tables. So if now we have our critical value, let's now move on. So now we have our critical value. We now have our critical value. We move to step number 4. Or we can actually, we need also to highlight the rejection criteria. Sorry. So still on number 3, you need to tell us when do we reject H naught. So for a two-tailed test, we say reject H naught if the test statistic if the test statistic is greater or less than. Because remember, H1 is saying it should either be less or above. It can't be 12. It should be less or above. So we say we reject H naught if the test statistic is greater or less than um, maybe the best way to write it is this way. We reject H naught if the test statistic is less than minus 1.96 or greater than 1.96. So for us to accept H naught, the test statistic must be within the range of 1.96. So we are saying if it's an inequality, we are saying we reject H naught if the test statistic is, we'll put it this way, 1.96 is less than test if the test statistic is less than 1.96 or so we reject under two cases. If it's less than 1.96 or if it's actually greater than 1.96. So the test statistic ikangoita diki kuna 1.9 ikaita diki kune the lowest value kana kuti ikaita hombe kune the highest value we reject. So the lowest value is negative 1.96. The highest value is positive 1.96. Ikaita diki we reject. Ikanzi yaita hombe we reject. So in other words, we are saying, let's have a number line here. On the number line, remember, we can have this point as, let me mark that point as 0. So on the number line, let's have this point as minus 1.96. Then let's have this one as 0. Let's have this one as 1.96. Remember on the number line, tine manumbers edu ukwa 0 anenge achiwedzera achidzika uku achikwidza. So we are saying we only accept H naught if the answer we calculate lies within this region I'm going to share. If the answer is 0.1, 0.2, up to 1.96, we accept H naught. And also if it's minus 0.1 up to minus 1.96, we accept. So this is the acceptance region. We only accept H naught in this region. But if the answer that we calculate is either less than 1.96 or above less than negative 1.96 or above 1.96, we reject H naught. So let's go and have our test statistic. That's step 4. Test statistic. The test statistic. So, like the question above, it's normal distribution. So we are using the same calculations here. Let's just change the variables, but the formula is the same. So the sample size is now 36. The sample size is now 36. The standard deviation was 3%, 0.03. That's 3% as a decimal. Then let's check what else were we told. Currently, it was 12%. They said currently the mean is 12%, which is 12%. Or let's just use, or 12% is 0.12. So we need the sample mean. Let's go and check the sample mean. The sample mean is 10. From the sample, they got 10%. Sample mean is 10. Now substituting in the formula to get our test statistic. Z count is equals to, we say, 0.1, which is the sample mean, minus 0.12, all divided by the standard deviation 0.03 divided by the square root of 36. So 0.03 divided by 6, that's 0.00 5. So, okay, from there, let's simplify. That's 0.01 minus so 0.1 minus 0.12. We get minus 0.002, 0.002, 0.02, in fact, divided by 0.005. So what would be our test statistic, or what would be our Z cow in this case? So our test statistic or Z cow would be -4. So the test statistic or Z cow, we're getting -4. So we're done with step number 4. Move to step number 5 to make a decision. Step number 5, this is where we make the decision. So the decision is based on what we said on step number 3. We said we reject H naught, this statement. We reject H naught if the answer we have calculated is within those range. So we reject H naught if the answer we have calculated is less than 1.96 or greater than 1.96. Since the answer is -4 and -4 is less than -1.96, we then reject. So we can say, since -4 is less than -1.96, we reject H naught. In favor of H1. So we reject H naught in favor of H1. Then finally, step number 6, conclusion. Conclusion is based on the case. What were we testing? What was the claim? So we are concluding that the second guess is right. So a stock market analyst claims that the average annual returns is 12%. You want to test whether this claim is true. So you reject H naught and conclude that it is not 12. So you're going in favor of H1. So we reject H naught and conclude that the average return is not 12. So we are concluding that the return is not 12, as claimed. So those are the steps. So this was a two-tailed test. This was a two-tailed test. We can also conduct the hypothesis test. So we've looked at a one-tailed test and a two-tailed test. So I've looked at one-tailed test and two-tailed test. So when do we use a t-distribution? Look at the next case now. In an advertisement, it is claimed that a certain brand of air freshener will last on average 40 days. So it is a claim that it will last 40 days. So again, we have a claim here that it will last 40 days. A random sample of 12 households took the following number of days to use up the air freshener. Test the claim made for the product using a 5% level of significance. Using a 5% level of significance. Okay, so in this case, the advertisement is saying that a brand of air freshener will last at least, take note of this, at least 40 days. They are saying 40 days or more. So the claim should be opposing the null hypothesis. They are saying at least 40 days. So, sorry, just a moment. Just hold on. Sorry for the disturbance. Let's proceed. Sorry for the disturbance. So I was saying, in an advertisement, it is claimed that a certain brand of air freshener will last on average 40 days. So this is the claim that's being made. It will last 40 days. The claim is that it will last 40 days. at least 40 days. So the alternative hypothesis in this case, it's not saying, because if they are saying at least 40 days, it means variability from 40 days and above. And the alternative hypothesis opposes what the now hypothesis is saying. So let's go to our steps. So this is example. Oh, our time is now running out. So this is now example 3. So for example 3, they're claiming that it lasts at least 40 days. So if you know your inequalities very well, at least 40, it means they are saying 40 and above. And we said that the now hypothesis iri kushanda nezviripo, iri kusapota kuti yes, it's 40 days and above. So it means if we are now testing the claim, we test opposing that. If they are saying it's 40 and above, it's greater or equal to 40. It lasts 40 and above days. That should be greater or equal to 40. So it's the now hypothesis is saying greater or equal to 40. So the alternative hypothesis says no. The now hypothesis is lying. So if they are saying that the fume lasts for more than 40 days, the alternative hypothesis will say, no, it can't be 40 days. It lasts for less than 40 days. So always the alternative hypothesis is opposing the alternative hypothesis. Opposes the now hypothesis. The alternative hypothesis opposes the now hypothesis. Then from there, let's move to the next part, which is determining the distribution. Determine the distribution. We need to determine the distribution. That's step number 2. So this was step 1. So in the exam, you can actually write step 1, determining the now and alternative hypothesis. Determining now and the alternative hypothesis. You can highlight that's your first step, determining the now and the alternative hypothesis. Then after that, you move on to step number 2, determining the distribution. That's step 2, determining the distribution. So for this one now, we are not given, if you look at the question, we are not given the standard deviation. A random sample of 12 households, we are not given the standard deviation, so we're not given the standard deviation and the sample size is small. We are looking at 12 households. So the standard deviation is not given. Tina the standard deviation, and also the sample size is small. Sample size is small. That is less than, the sample size is small. That is less than 30. Therefore, we use the, therefore, we use the t-distribution. Under these conditions, when the sample size is small and we are not given the population standard deviation, we use the t-distribution. So that's where I want us to end for today so that we don't mix up this and cause confusion. So we'll finish up the example, a t-distribution in the coming session. And after the t-distribution, after the hypothesis testing, the main session or what you're supposed to introduce in the coming session is supposed to be a regression and correlation. So after regression and correlation, it means we'll be left with, before we can start looking at questions, let me just check. So after regression and correlation, we do time series analysis and index numbers. So we still have 3 topics ahead of us. So there's still a lot to be covered. So for today, thank you so much. Let's end here.